What's up, mathletes? This is section 3.52, solving quadratic equations by completing the square. And the last video, this video, and next video all have completing the square in the title. And here's what completing the square looks like. We're actually going to complete a square. Because here's an incomplete square. This is x squared plus 8x plus, and I don't know. It's a blank. In order to complete this square, you have to have a 16. If you wanted to say, hey, we need something in perfect square trinomial format that had x squared, like an a squared plus 2ab plus b squared, and you wanted to figure out what this b squared value was, it would be 16. And if it were 16, then you could say that a would equal to x and b would equal to 4, and 4 times x is 4x doubled is 8x. So you would be able to factor this and say it's x plus 4 squared, going from here down to here. But the question is, how could you calculate 16 in the first place? Like how would I filled in the blank 16, and I didn't tell you exactly how I got it. Let's take a look over here. X squared minus 2x plus, I don't know. Well, if we actually had a 1 here, if we completed this and made it a square, then we'd have a equals x. That's got that from here, and b is equal to 1, and we would be able to use the formula x minus 1 squared. So the question is, how can you complete the square? How can you fill in the blank with a number that would make this a perfect square trinomial? The answer is, you look at this linear term right here, and the check that we often do is 4 times x is 4x, and doubled, it gives you 8x. So what you really got to do is reverse that check. You've got to take the 8 and cut it in half. 8 cut in half is 4, and then squared is 16. And that's how you can calculate what completes the square, what number gets put in the blank. 2 cut in half is 1, squared is 1. So that's how we can know what number is over here that would allow us to factor it, would allow us to factor it as a perfect square. You were completing the square. So let's solve by completing the square. Here, 8x, this is x squared minus 8x. This is not a perfect square trinomial. It is not an a squared plus 2ab plus b squared format. But we can make it be in that format by completing the square, by adding 16 to both sides. If I were to add 16 to both sides, then you could see that this is going to be, if I somehow magically add 16 to both sides, then all of a sudden, it is, yikes, it is now in perfect square trinomial format, x squared minus 8x plus 16. A would be equal to x, and b would be equal to 4. So how did I know to add 16 in the first place? Well, I took that 8, I cut it in half as 4, and I squared it to get 16. So it's all going to be about looking about this this linear terms coefficient here, cutting it in half and squaring it. So we get here, now that we've added 16 to both sides, 84 plus 16 is 100. Now we can take the square root of both sides, and now we can add 4, and now we can get solutions. This is, so x squared minus bx is equal to a number. That's going to be the format that we're now able to solve by completing the square. Here, x squared plus 10x equals 11. This is not a perfect square trinomial, but you can make it be one by adding 25 to both sides. How did I know 25? Well, I looked at that 10, I cut it in half, and I squared it, and I got 25. 10 cut in half is 5, squared is 25. Now that I've added 25 to both sides, it is a perfect square trinomial, and then we can solve this. This is x plus 5 squared is equal to 36. Taking the square root of both sides, you get this. Subtracting 5, you get this. And then adding and subtracting, you get two different numbers. The big idea here is, in order to solve an equation in this particular form, x squared plus bx equals a number, you can complete the square by adding b divided by 2, b cut in half, squared. All right, let's practice. First step, all the preliminary work, it's got to be putting an x squared plus bx equals p form. And then we're going to solve by completing the square. So here, I know I said that having it all set equal to 0 is really important, but here what we're actually going to do is we don't want it to equal to 0. We're going to let this equal to, we're going to put it in x squared plus bx equals p form. So this is x squared plus 18x. We're actually going to add 4 to both sides in here. So now we look at this b value, it's 18. We're going to cut it in half. That's 9, and squared is 81. That's the preliminary work we got to do. Now that we've added 81 to both sides, we've got a perfect square trinomial. We've forced it to be a perfect square trinomial. And that's where a equals x and b equals 9. So x plus 9 is squared is equal to what 4 plus 81 is. It's 85. Taking the square root of both sides, we get that. And then subtracting 9, we get that. Here, definitely not in x squared plus bx equals p form. We got to add 13 to both sides. And now that we have this, we can look at that 4x, cut it in half. That's 2. Square it, we get 4. So the number we have to add to both sides is 4. I must have copied and pasted my same error multiple times. Okay, so we get x squared minus 4x plus 4. That's actually a perfect square trinomial. A is equal to x, b is equal to 2, and so we get x minus 2 squared is equal to 17. Taking the square root of both sides and adding 2, we get this. Yep, copied and pasted the error. All right, so here we've got, this is not a perfect square trinomial, but we can make it be one. Let's add 65 to both sides, and then to figure out how to complete this square, we have to take the 8, cut it in half, we get 4, square it, we get 16. So now that we have to add 16 to both sides, and x squared minus 8x plus 16 is equal to these two things. Notice we're adding 16 to both sides. And now it's a perfect square trinomial. A is equal to x, b is equal to 4, and then we have x minus 4 squared is equal to 81, which we can take the square root of both sides. We're undoing the square, we're undoing the subtraction. We get x is equal to 4 plus 9 and 4 minus 9. Those two numbers are going to be 13 and negative 5. Just wanted to take a moment to say that there is no finer breakfast on the planet than a breakfast burrito. Would you agree? Tell me what you think. All right, so first arrange in x squared plus bx is equal to p form. So the new thing is going to be that we've got a number here. And that's going to introduce a lot of fractions, honestly. But I'll tell you what, working with fractions is going to be a whole lot easier than having to deal with the alternative format. So I think let's settle on fractions. We need to arrange it into x squared, the no number in front, plus bx equals p form. So that means we've got to divide all the terms on both sides by 4 to get this to be x squared minus 3. 12 divided by 4 is 3. 27 divided by 4 is, we can just write 27 fourths. Let's add that 27 fourths to both sides. And now we've got x squared plus bx equals p form. To figure out what we have to do to add to complete the square, we have to take this number, 3, and we have to cut it in half. That is 3 halves. When you square 3 halves, that's 9 fourths. And 9 fourths is the thing we got to multiply to both sides. Add to both sides. So we get x squared minus 3x plus 9 fourths is equal to 27 fourths plus 9 fourths. Now 27 fourths plus 9 fourths, that's 36 fourths, which actually happens to simplify. We get 9. 36 divided by 4 is 9. And now we can take the square root of both sides, and we get x minus 3 halves is equal to plus or minus 3. And then you can add 3 halves to both sides. You get x is equal to 3 halves plus 3, and x is equal to 3 halves minus 3. When you actually do the math on that, you can get these two numbers here. It's a lot of fraction work, but that's okay because we're strong and we know fractions and we can do it if we slow ourselves down. Here, we can get rid of this 2, dividing all the terms on both sides by 2. The greatest common factor is equal to 2. So therefore we have x squared minus 4x minus 12 is equal to 0. Adding 12 to both sides, we get that. And now we have to figure out how to complete the square. It's almost a perfect square trinomial, but if you see, you take that 4, cut it in half is 2, squared is 4. So let's add 4 to both sides. We get x squared minus 4x plus 4 is equal to 12 plus 4. Adding them together, we get 16, and taking the square root of this, using the formula, because a is equal to x and b is equal to 2, we're going to have x minus 2 squared. If you were going to try and FOIL that out, you get back to the original over here. Great, we've got x minus 2 squared is equal to 16. And now we're going to just undo operations. We're going to undo the squared here. We're going to undo the subtraction here. And we get x is equal to plus 2 plus 4, and x is equal to 2 minus 4. And when you do those addition and subtraction, you get 6 and negative 2. Here's one that is even more complicated, but that's okay. We're ready for it. First thing we got to do, well, we could do this in either order, but we're going to move the 1 over to the other side, and I'm going to divide all the terms on both sides by 2. When I do that, I get x squared, and then the b term equals the p term over here. X squared minus 3 halves x is equal to negative 1 half. Now, I got to figure out what to add to both sides, because it's going to be a fraction. I'm going to do some side work over here, and I would encourage you to do the same thing. They're going to take this b value, 3 halves, cut it in half. It's the same thing, and cutting something in half is the same thing as multiplying by 1 half. And when you're doing it with fractions, I think multiplying by 1 half is a lot easier to think about. 3 over 2, and write this out, because it's not going to be easy to think about in your head. 3 halves times 1 half is going to be 3/4. Squared is 9/16, and that is the number I need to add to both sides. I need to add 9/16 to both sides. I would even recommend, I don't have space in my screen, but I would even recommend when you have to add negative 1 half plus 9/16, it's going to be kind of tricky to just think about and stare at and come up with the answer. Here. Oh, I did write it out. I knew that I was just going to need common denominators over here. 2 and 16, the least common multiple of 2 and 16 is 16. So I changed 1 half to negative 8/16. And now I can actually add these two fractions together. Negative 8/16 plus 9/16 is 1/16. I'm going to take the square root of both sides. You remember, this is the number that I write here is the square root of this. 9/16, the square root of that is 3/4. Because what number times itself is 9/16? That's 3/4. So x minus 3/4 squared, I'm going to take the square root of both sides, and that is x minus 3/4 is equal to plus or minus 1/16. That was the result of the addition here. But I can even take the square root of 1/16. Just like the square root of 16 is 4, the square root of 1 over 16 is 1/4. That's the fraction that when you multiply it by itself, you get 1/16. You can also take the square root of 1, and that's 1, and the square root of 16, and that's 4, and there it is. I'm going to undo the subtraction with addition, and now x is equal to 3/4 plus 1/4, or 3/4 minus 1/4. And when you do those two things, these are the two numbers you get as your solutions. Wow, that's a lot of work with fractions. The key here is to not try and do it in your head, y'all. The key here is to do your side work over here, to do your common denominators, write it all out. That way you're going to be much more reliably going to figure out what's going on. Here, 3x squared plus 2x minus 1 is equal to 0. Let's add 1 to both sides. Let's divide all the terms on both sides by 3 so that we get this x squared over here, and the bx equals the p term over here. 2/3. Let's cut it in half by multiplying by 1 half. 2/3 times 1 half squared. That's going to be 2 over 6 squared. 2 over 6 is just 1/3. 1/3 squared is 1/9. So we're going to add 1/9 to both sides. And now this is a perfect square trinomial. Yay! 1 over 3 plus 1 over 9. We need common denominators. That's 3 over 9 plus 1 over 9. It's going to be 4 over 9. And so here we have the square root of 1/9 is 1/3. The savvy student might realize that this number right here, 1/3, is going to be the same as the result of 2/3 cut in half, which is 1/3. but that's a pattern you can use or not as you wish. X plus 1/3 squared is equal to 3/9 plus 1/9. Add them up, you get 4/9, and take the square root of both sides. You get x plus 1/3 is equal to plus or minus the square root of 4/9. You can take the square root of 4 and get 2. You can take the square root of 9 and get 3. And subtracting 1/3 from both sides, you get x is equal to negative 1/3 plus or minus square root 2/3. Now, if you were to simply add negative 1/3 plus 2/3, you get 1/3. But I wonder what you would do if you subtracted negative 1/3 minus 2/3. You get something that you can actually simplify into. So take a moment to do that right now. And I believe that is the lesson for today. Oh no, sorry to get your hopes up. We got one more that I want to do. Just because it's so complicated, it's so tricky. Let's make sure we do enough examples. 2x squared plus 5x plus 7 equals 0. There's nothing simple or happy or easy about this problem, but that's okay. We can do all the preliminary work and all the fraction work we need to solve it. We're going to subtract 7 from both sides. We're going to divide both sides by 2 so that it's an x squared plus bx equals p format. 5 halves. Wow, okay, so the side work we got to do, 5 halves. Let's cut it in half by multiplying by 1/2. That's going to be 5/4 squared is 5/4 times 5/4 is 25 over 16. We're going to add 25 over 16 to both sides, and there we go. We are going to factor this using the formula. A is equal to x, b would equal to 5/4, and so it's x plus 5/4 squared. So we added 25/16 to both sides, 25 over 16. In order to get common denominators, we need to multiply the numerator and the denominator by 8. We get negative 56 over 16. There's nothing simple or convenient about this. This is as hard as it gets, y'all. Completing the square isn't going to be any harder. And so negative 56 plus positive 25 is going to give you negative 31. When you I'm just rewriting the whole thing over here. This is a duplicate top line, so you can see the continuation of what's going on. You don't have to write it if you don't want to, but if it's there, it's fine. So we're going to take the square root of both sides. That is negative 31 over 16. Nothing simple about that. Here we're going to have x plus 5/4 is equal to plus or minus a negative number. You can see the I coming. X is equal to negative 5/4 plus or minus. You can take the square root of 16, and that's 4, but you can't take the square root of negative 31. The best you can do is factor out an I. And look at this. They both have 4s, so I'm going to actually combine these two fractions into one giant hunkin fraction. X is equal to negative 5 plus or minus I root 31 over 4. Good night. That's complicated. But it's not impossible to do, and we're going to practice, and we're going to get good at it. So I can't wait to practice and help you get good at this kind of thing and walk with you in it. So take care, and I'll see you in class.